So the written assignment is about part of the way a spell checker works. And it uses an idea called the Levenshtein distance, which measures the number of substitutions, additions, or deletions that are required to change one word into another. So for example, the word cat. I can change the word cat into the word C-A-R by just replacing the T with an R. So these guys have a Levenshtein distance of 1. If I then changed car to cart, then again, that from car to cart has a distance of 1 because I did an addition. Okay, with car to cat, I did 1 substitution. Okay. Now the addition can be anywhere, so I could put the R in between the A and the T. So that means I can connect car and cart because they are also 1 apart based on the Levenshtein distance. Okay. So instead of an addition at the end here, I could put the addition of R over there. Let's suppose we have, how about cats? What's the Levenshtein distance between cats and car? Now I can't draw a line between them because I can't do a single substitution, addition, or deletion to get from car to cats. But I could do a substitution, then an addition. So the distance between cats and cars is 2. So when we draw a graph based on the Levenshtein distance, the only time we connect words is when their Levenshtein distance is 1, which means that to get from one word to the other, you can use a single substitution or a single addition or a single deletion. So help me out. What other words could I make here? Well, we could certainly make carts. And we could change the C here to an F, and we could spell fart. It's a word that makes everybody giggle. And from fart, I could do farts, which carts and farts are only 1 apart because it's C versus F, so those 2 can be connected. So every once in a while, you make a new word, and you're like, oh, I could connect that to a word I already have. Okay. So the goal of this assignment is I'm going to give you a different word to start with, and then you're going to make as many real words as you can based on that word, and connect with a Levenshtein distance of 1. And again, if you make up a word that could be connected to something that it wasn't connected to initially, you got to make sure you make that connection. So you want to make sure your graph is complete as possible. So it's kind of fun. And this is kind of how a spell checker works. How does a spell checker suggest words for you? Well, it looks in the dictionary for words that aren't that far apart based on this Levenshtein idea. And then it says, hey, try these words. Sometimes, though, your word is so misspelled that the spell checker's like, I can't find anything very close to this. So sorry, you're on your own. That ever happened to you guys? Happens to me sometimes. It's like, damn, I messed it up that bad. So there's some more examples about what the Levenshtein distance means, which is similar to what I just showed there. And you're going to do this based on the word M-A-K. And then I want you to make as many words starting with that as you can and diagram them out with a graph, making all the connections you can find, and do at least 10 other dictionary words. And please do more, because this is kind of fun once you get going. So try to do more than 10. And then take a picture of your graph. And then I would just like you to make a couple of comments on this idea. So here's a similar graph a friend of mine made based on the misspelling here, D-O-Z. And then he had a bunch of other words that ended up being connected. And you can see there's a lot of interconnections going on there. So that is your written assignment, to diagram out the idea of a Levenshtein distance given a starting word, which is one way we program a computer to do a spell check for you to find suggested words that are close to what you tried to do.